In a world where some ordinary guy can DIY his own CNC plasma rig, using free plans for a mostly printed CNC from Ryan at V1 Engineering, and some free open source operating system and control software from Linux CNC, what's left to do but add laser crosshairs for targeting cuts, and then making cool stuff just because you can. Seriously, today we go from this cool DIY plasma rig, but without the lasers, to this. And along the way, I'll show you the entire design process from start to finish using a free version of the SketchUp 3D modeling software to go from concept to ready-to-print files. Ready, set, make.
Hi, this is Doug with Design 8 Studio, and I'm looking to put some little red sightline lasers on my new plasma machine. So I bought a pack of 4 of these, and when you go to shop for them, be careful to make sure you get the kind that don't shoot a straight dot of laser, but rather have a special distribution lens that sends out a line of laser light. So I got 4 of these, and I got a 4-pack of these little battery packs. They're made to hold AA batteries. And the way this works, if you put one AA battery is 1.5 volts. And if you put 3 of them in series, then you get 3 times 1.5 volts, or 4.5 volts. I want to power 2 of them with a single battery pack for my plasma. So just a quick bit of soldering, 2 wires in, 1 wire out. I'll be able to position them on the laser so that I get a crosshair where the laser, where the plasma cutter is going to come down. And so I've just got to heat shrink this little bit onto that set there. That's going to work really good. I'm probably just going to use some either double stick tape or Velcro to put this on top of the core or on top of the drag chain mount on my LowRider, and 3D print a little holder that can attach these to my magnetic breakaway. Okay, now it's just a matter of getting these mounted and aimed properly, and we'll have a nice sightline system.
So I had started working on this in SketchUp, and I'm using the free version of SketchUp. And just a few steps into it, I thought, well, why not turn the screen capture on and at least record what I'm doing? And so I used the stepping through the undo stack to get back to this point. So I'm just going to step back through the steps that I've done and kind of talk you through it. First is I have a set of precision lines stored inside one of these groupings for the dead center of the plasma torch. And you can see it at the top right there, kind of a asterisk looking thing. And so I dropped a guideline going out in 90-degree opposition, right angles to each other, and then backed out of that. And then once I'm outside this grouped geometry, I can draw lines without it sticking to any of this geometry or messing with this geometry. The first thing I did was on the bottom of the torch, I added a 1.5 millimeter line that sticks out the bottom of the plasma torch that communicates where the top of the metal would be when I'm cutting. But that's not really what I want the lasers to point at, because this whole thing will be up by about 2.6 inches when I am sightlining in with the laser. So I really want a line that goes down 2.6 inches to where the surface of the metal will be when I'm up high and moving around for placement concerns. And so I drew that 2.6 inch line, comes to here, and this gives me where I want to sight things in. Then I drew, I think next in the stack, I drew lines, 50 millimeter line on this guideline, 50 millimeter guideline, 50 millimeter line on this guideline, and then I just start, I move those down to about where I want the top of the laser modules to be, and then I start connecting those to get some pointers in the direction of where I want the lasers to be focused. And so I dropped a guideline along here, 36. You can see this little dot appear right here. That is a guideline that's dropped. I then did the same thing on the other side, causing that one to drop. Again, these are 36 millimeters from the tip of this 50 millimeter line. And then I made connecting lines from those points down toward my focus area. So this gives me a rough idea of where I want to put these laser modules. Probably somewhere around in here, and obviously pointed with, so the central axis of the cylinder is pointed to this location right here. Obviously one of them will have to be turned so its line is this way. The other one will have to be turned so its line is this way. So the next thing to do is to mock up the laser module itself. And the laser module, for just really simple configuration, it is about 9 millimeters. I think it was 8.95 that I measured. And so I'm going to use a circle with, let's try a circle set to 48 sides. I'm going to be good with that. And then it was 22 millimeters tall. So I'm going to use the push-pull tool. I'm going to go up, type 22 and hit enter. And so there's my laser module. So triple click on it, selects everything. I'll right click and make component, and we'll call it laser red sightline. I don't know what the technical name for it is. That's going to be fine. Now if I move around underneath, it's going to be pretty important to be able to hit the dead center of that. So I'm going to drop that little thing there. I can go ahead and put the other wings on it. And then up top we want to do the same thing. And I'm going to do, on my Mac, I'm going to do Control Shift Command G to exit that component. And if I do Command 2 and then Shift Z to zoom to extents, I'm now looking up at the bottom of my floating Z mount, looking up at the bottom of my torch holder and looking up at the bottom of this laser piece. So I'm going to press the M key to move, and I'm going to move this over and put it right on this point, and O for orbit, and I'm going to orbit around. And one thing I really appreciate about SketchUp is the ease with which you can get just the precision that you want on rotating objects. If you want to rotate something in a way that is normal to a certain axis, you get the blue when it's normal to that axis, and then if I rotate back this way, as soon as I get below the horizon line, the background changes to blue. And if I hit the rotate tool now and just hold it off anywhere in that area, then it gives me green to indicate I'm normal to that. And then if I spin around and I get red to let me know that I'm normal to that one. But there's another neat feature, and that is that if you go to the rotate tool and you put the tool onto any surface, it will give you normal for that surface. In this case, it's not a surface on the laser module that I want. It's this surface right here that you may not have understood why I connected a triangle to make that plane. But this is one reason. You'll notice this is neither blue nor green nor red. It's none of the three main axes, X, Y, or Z. I'm going to hit for X-ray vision, which I've got a hotkey for that. Not sure. I've used same custom hotkeys for so long, I'm not sure which hotkeys are native to the program and which ones are my custom add-ons, but for me it's Shift X for X-ray. And now I can see these lines right through the laser module. But there's a really handy thing about the rotate tool. Right now, the module, the laser module, is what is highlighted. So it is what will be rotated. And when I position this protractor looking tool, when I position the center of it on something, that center point becomes the pivot point for where it will rotate around, and the plane that I have the tool oriented to becomes the plane in which the rotating happens. So whenever you get on a plane that you want, you can hold Shift and it locks in that plane on that item. And then I can move down to the center point of the bottom of the laser module, tap with the mouse, and then move up to the top of the laser module. And when I begin to rotate, I'm rotating not just around that bottom center point of the laser module, but I'm rotating consistent with the axis that I selected. And when I choose any point and then tap with the mouse again, then it will lock that rotation in as having happened around that particular axis. And so you'll see here the bottom is still right smack on point, and now the top is on point. Now it may be that where I really want to be is not on this line, but maybe on another angle out along this line somewhere, maybe here or here. So I can always go back and redo this. But what I'm going to do now is I'm going to copy this in this orientation, Command C. I'm going to hit Command Z to undo, and then I'm going to hit Control Shift V to paste in place. And now I've got the original one to work with, plus the rotated one. So for now, I'm going to create a layer called InProg for In Process. And this is a layer that I'm going to be able to turn on or off as needed. I'm going to hide it for now. And I'm going to highlight this again, shift around, repeat what I just did a moment ago. But this time, I'll be rotating it to this one. So again, rotate tool, which for me is a hotkey Q. and I don't remember if that's native to SketchUp or if it's my own custom one. But for me, hotkey Q is for rotate. I guess think of the fact that the Q is round and it has a little hatch mark on it that looks kind of like a protractor angle mark. That's the only way I can remember it. So again, I'm going to hold shift to lock in the axis that I'm using to rotate. And now I'm going to position the center of the rotation tool on that endpoint, tap with the mouse, come up to this point, tap with the mouse, and now I'm beginning to rotate along that axis. And I'm going to scroll out, scroll back in. I'm using my trackpad to do that. And I'm going to tap on this point. And at that 3 clicks, I've now positioned this laser module in the plane that it needs to be. And I can now take this one out of the improc layer, put it back on layer 0. I'm going to copy this one and Control Z to undo and paste it in and just repeat the improc thing that I did a minute ago. And now I've got this one unrotated. I'm going to keep it and store in case I want to go back and redo my rotations from scratch again. I'm going to make this one in the hidden improc layer, in-process layer. Turn that back off. So now I've got 2 laser modules, and they're not placed at the right elevation, but they are placed at the right orientation. And it's a handy thing about SketchUp. When you go to move something, if you're moving it along a line, it's really good at magnetically sticking to that line. And if for some reason you're having difficulty, if you go to hotkey T for the tape measure and put a guideline along the line that you want to follow, that kind of really double ensures that you'll be able to follow that. But if I grab this and move now, as I position, you'll see that line lights up in pink. And if I hold shift while that is lit up, it constrains it to that line. And so I've now moved it up. And as we look in here, we see that while there is room for the laser, there may not be room for the plastic that's going to go around it to hold it. But if we're holding it around the bottom, it's pretty tight up against the mount. So I may have to strike another line further out and mount it on that other line further out. I think we'll do that. So I'm going to Command Z to undo that, and Shift X for X-ray. And I'm going to strike another line. This time I'm going to put a guideline from here, and I'm going to go out, let's say 5 millimeters. So I just clicked here, moved over, typed a 5, and then hit enter. It gave me another guideline mark point. The guidelines in SketchUp kind of correspond to construction lines in Fusion 360. But guidelines can either be infinite that go off in either direction without end, or they can have a start and end point like the one that I just did. And when you constrain a guideline to have a certain length, it puts this little plus sign at the end of it. So I'm going to repeat that over on the other side. O key for orbit, T for tape measure, click, type a 5, hit enter. Now I've got another one of those little marks there. And now I'm going to L for line, tap, go down to this center point here, snap onto it, tap again, and O for orbit, L for line, click, go down to the center point, click. So now I've got a new set of lines to work from. Same thing again, I've got this laser module highlighted. I'll hit Q for rotate. I'll get on this plane. I'll hold shift to lock that plane in. I'll come down to this center point, tap to lock that center point in. Then I'll come up to this point, tap to say that's where I want to start the handle for the rotation. Come up to here and lock onto this one and say that's where I want to swing the rotation around. That is approximately 1.8 degrees. Tap again. And so before, after, undo, redo. And now I will tap on this one and do the same thing. This one's highlighted now. Q for rotate. Shift to lock that in. Set the point right there. Tap. Come up here. Tap. And come up here and tap. And now I've constrained the movement for another set of reorienting steps on these two laser modules. So now I'm going to grab this one. I'll put a guideline here just in case again. I don't know if that's necessary or just kind of habit of mine. It lit up that line, so while it's lit up that line, I'm going to hold shift to constrain it to that, and I'm going to go to that point and let go. So I'm positioning these laser pointers out in space, but they're a little too high, right? Because I don't want this plastic edge to block the bottom of it. So I'm going to use Command 3, which gives me a front view, and then Shift Z to zoom to extents. And I'm going to find out how far down I have to go. I've got to go from about there. I'm using T for tape measure there, down to, okay, so that's 13. That's 13 and a half millimeters down. I like that. So just kind of to give the maximum visibility of the laser, I'm going to move this down about, let's say, 14 millimeters. Shift 3 for front view, Command 3 for front view, Shift Z for zoom extents. And now we've got the laser diode lens down below the lip of this torch holder. And as you can see, when I go to this view, there's not going to be anything blocking line of sight here. Not only for the point that it needs to, but some more of the crosshair going on toward the back of the machine. And again, if I do tape measure, click and click, it shows in the lower right corner 14 millimeters. That was 14 millimeters down. So now I'm going to get this one. I'll go ahead again, drop a guideline just in case it helps. I don't know if that's just habit. I'm going to move this up this line. All right, and now I'm going to move it down by 14 millimeters. I'm going to type 14 and hit enter. And again, Command 3 for front view and Shift Z for zoom extents. And that's looking pretty good. So typically 3D printing, if you want a really tight fit, you could go for 0.125 of a millimeter off of the item that you're trying to fit to. A comfortable fit would be going 0.25 millimeters off of the item you're trying to fit to. It's common if you get any bit of elephant's foot or even a tiny bit of over extrusion, you can wind up with an opening too small to fit the thing that you're trying to fit. And so I'm thinking in terms of taking advantage of the flexibility of the plastic to deliberately make the opening a snug fit, but leave a gap where a screw would tighten it so that it could be kind of pushed into and then snugged and tightened down. So I'm going to Command C to copy this and Control Shift V to paste in place. Right click on the new copy, which is now on top of the old copy, and make it unique. And we're going to change it to laser holder. And for now we'll call it right, because the other one can match its appearance exactly, but it will need to be mirrored. So if I take this and Command X to cut it, you'll see that I still have the laser there, and Shift Command V to paste in place the laser holder. So if I double click right now, the question is, which one am I in? If I go to components within the model, there's something weird going on here. It's like every click is a right click. I don't know what's going on there. So I'm going to temporarily move this one over in the red direction by 50 millimeters, remembering what I've done, and I'll see that that's the laser module. So I know that this one is the laser holder. The laser holder is going to become a negative or female, where this was a positive or male a minute ago. So when I double click on this, I can now delete these lines, and I'm going to go for 0.125. So I'm hitting F for offset. Again, that may be a native hotkey or my own custom hotkey. I don't remember. F for offset, and I'm going to type in 0.125. Hit enter. Oh, that's looking pretty tight. I don't think that's enough. F for offset, and I'm going to go 0.25. Okay, let's go 0.2. Okay, I'm okay with 0.2. So in this instance, I'm now going to click on this one, and now we're going to talk. This amount is going to be the gap between the laser module and the inside of the holder. But for now, I'm going to use this plane for another offset jump. I'm going to hit F for offset. Now we're going to talk about the thickness of the plastic. And I'm going to go with 2.4 millimeters. Now I can delete this and delete this and this whole cylinder, everything here. I'm going to triple click on it and delete it. And now if I take P for push pull tool, go down, type 22 and hit enter, and Command Control Shift G to exit that group. Let me go ahead and paint this kind of a gold color, because the real thing kind of has a brassy or gold color to it. And I'm going to move it back now 50 millimeters, type 50 and hit enter. So now we see that laser module inside the holder, but the holder is too tall. There's no part of the laser mount sticking out for turning it or rotating it. So I'm going to double click to enter into the editing of this component. P for push pull tool. I'm going to go down. So it was 22. So if we go 11, let's go 9. So if we go 9, this remaining thing is 13 millimeters tall. So then that's how much of the laser module would be sticking out of the top of it if the bottom of the laser module was exactly lined up with the bottom of the holder. Okay. Now we need to think in terms of the gap and a flange on either side of the gap with a place for a screw to go through and a place for a screw to grab onto. So I'm going to double click again. Matter of fact, let's take this plane right here, and I'm going to use L for line tool, and I'm going to go right here, right where it gives me that little indicator. I'm going to go to this indicator, then I'm going to grab that line, double click, and then Control Shift V to paste in place. So that's the plane right there. So I need a pretty decent opening. So let's drag a guideline away from here. That was T for tape measure, hotkey T. Let's drag a line, let's say 0.75. That's a lot. Let's try 0.5, okay? And then the other way, 0.5. So if I grab that nearest slot, that nearest circle side segment is 0.6, and that's not bad. I'm going to grab that one, and I'll go parallel this way. Let's put this guideline on that and put this guideline on that one. E for eraser, erase this one. L for line tool. Let's put a line right here. Put a line right here. Delete this line. And now if I highlight this plane here, this face, push pull tool, push down till this point and let go. Then now I've got, let's go ahead and delete this plane. Sometimes it deletes it for you automatically. Delete those lines in between. So now I've got my holder, and I just need my flange. So the flange on one side would be where the screw will sink into. The flange on the other side would have where the head of the screw is. And it's up to us whether we want to just make the hole tight, a little bit small so that the screw threads bite into the plastic, versus some kind of over-engineering like a nut on the other side or a heated insert. And I think just some plastic for the screw to kind of cut its own threads into should be fine. So by the way, I made this initially with 48 sides. The circle had 48 sides. There are hidden lines on the places where the sides meet their joining to the next side. And if I hit Control Shift X, which is I'm pretty sure a custom hotkey that I created, it turns a hidden geometry on, and then a Control Shift X turns it back off again. So think in terms of, again, for that screw to have some room to bite into, we probably need at least like 4 or 5 millimeters. So I'm going to come here, come out, let's say 5 millimeters. And that's pretty close to this one. So let's go ahead and let it be that one. I'm going to snap it right onto that one. So then if I get a line here, pull it out by, well, let's say the head of the screw is probably 8 millimeters. Probably need a couple of millimeters on either side of it. Probably need about 12. And that would be from this point here. So what if I take and put a guideline from here to here, and then bring that guideline out this way by 12? That's where we need to go to. So I'm going to L for line, bring a line out to here, over to here, back to here, and I will push pull. P is the hotkey for the push pull tool. There, we've got that. Okay. Fancy. And this side, it doesn't have to be quite so thick. 2.4 millimeters. Let's go a little bit thicker than that to get out to this line right here. E for erase. And again, we're going to go click,
with the line tool, which is L hotkey. Click, click, click. Now the push-pull tool has memory. It remembers the last distance by which it extruded. So if I tap on P and then double click, it will automatically go to match this one. And this distance from here to, say, about right here is 4.25. This distance, 13. So let's do this. I'm going to select this line, this line, this line, this line, and this line. Choose this tool and go 4.5 and generate the geometry, and it knocks those corners off like that. These lines here can technically be erased, as well as that line there, that line there. They wouldn't hurt anything to leave them, but go ahead and erase that and that. So we're off to the races now. We've got a nice shape here. I'm going to delete the guidelines. Now we just need some way to mount that over to this operation here. One way to mount it would be to loosen this screw in this hole and then reinsert that screw, or a longer screw, through a piece of plastic that is attached to this. That's one way to do it. Another way to do it would be to run zip ties through here and through corresponding holes in a piece of plastic out here that comes over and is connected to this. So those are options. Those are options. Thinking, thinking, thinking. Okay, so thinking in terms of this screw head right here is really close to this. So trying to get up around here, and if I had it to do over again, I would have either put these two closer to each other so that there was more gap between them and the screws, or even just done one of them instead of two, so there would be more room around them. So I'm thinking in terms of loosening the screw that's in here and putting it back through something. So I'm going to copy this plane right here, this face rather. Copy that. Command Control Shift G to exit that group. Exit again. And double click on this. And now Control Shift V, which is a custom hotkey to me, if I'm not mistaken. And this part we can now, like, I've got an extension called Nroth Face Creator, and I've got a custom hotkey set for it of Control Shift F. It's going to create that face because I had that line highlighted. Let me show you that again. You pick lines, pick one or more lines on a face, and then activate that extension, and it generates a face between them. So I'm going to temporarily generate a face between this just simply so I can highlight that and then use the offset tool to get an offset to work with. I can delete this now, and I'm going to run a guideline over here, run a line down to here, run a line out to this point and up to that. Oh, that's not what I wanted to do. Right there. Put a line L hotkey from there to there. So I can delete this now, and I can delete all of this. And I'm going to select all of this curvature, as much of it as I can at one time, by using the Tools Select Curve, and it gets it all. I've assigned a custom hotkey to that for myself of Control-Shift-C, and again Control-Shift-C to select curve. So this, and again, so this can become our basis. I'm using P for push-pull and bringing it out. And we've designed something that, unless we do some work to change some of these face angles here, it's going to be pretty hard to get this to print. So let me undo that and think in terms of this plane here. If I do an F offset and I bring a really big offset here, I'm just doing that just to get a working plane. If I come down, if I drop a guideline here, you'll see that there's an intersection point with this plane. And if I go from here, L key, hotkey, from here to here, and then on from there, L, from that X to there, I can delete this plane now, and I can delete this and this and this. What happens now when that comes up? It's still not right. Okay, so rather than delete that plane that I deleted a minute ago, I need to leave that. Just delete this. Shift X for X-ray vision, delete this and this. What I really need to do is just go ahead and extend the bottom of this over, and then bring my shape out, and then use that plane as a cookie cutting tool to cut the bottom of it off. So if I bring this over now, and then this also, when I bring them over, you'll see that I can assign a non-normal new bottom to that that's congruent with this plane here, and it will allow this to be printed using this plane as the side that will go against the print bed. So I'm going to click tap with the L hotkey for line tap, and again tap over to here, on over to here, same thing around the back side. E, erase. E is the hotkey for the erase tool. Oop. I'm going to use the Enroth Face Creator extension to try to get a recognizable plane that can survive. Why is it? don't know why I don't have a plane here anymore. Okay, that's good. Using the L hotkey for the line tool, and I'm trying to get a face for across here that will be a standalone face. And still struggling somewhat with that. Okay, so for right now, I'm going to hide the invisible lines. My hotkey for that is Shift X. No, Control Shift X. I'm going to select that cylinder and that side wall, and I'm going to ask it to generate geometry where those two meet. Right pointer tool, right click, intersect faces with selection, and you'll see that it drew those lines. And one of the little tiny segments was too small for SketchUp to want to mess with it. I'm going to put a guideline from here to there, and that guideline is going to serve. I'm going to push pull this in by I'm going to press Option and push in by 2.4, and now I'm going to come from there over to here, and the idea here is that this part is going to be gone. This part is going to go up to get to the screw hole, and this part is going to be printable to keep everything tied into this part. I'm going to take that same line and bring it this way over to this point. Same thing. I'm going to grab from here over to here. And it found an issue. From here to here. Okay. Let's reverse this face because it's got its inside facing out. And this is now not viewed as intersecting this line is not viewed as intersecting this plane. So there's a trick I found that works. I click on this line and I do extensions in Face Creator, which for me, my hotkey for that is Control Shift F. And when I tap that, it makes it where I can select these two independently. And I want to push pull and extrude that through to there. So there is my wing for my ring, wing, whatever you want to call it, for the screw. Oops. Okay, so I need to remove that I cut this plane. Let me back up. I selected this plane and I went Command X to cut it so that I could get in to select this to delete it, and now Control Shift V to paste in place. So that's properly hollow now. X-ray vision, Shift X, I see some stuff that needs deleted. Now in an ideal world, this plane and this plane and this plane, they're all the same. And I can see I need an intersect with this and this. Right click, intersect with selection, get that. Not sure why this line is so far off from where I imagined it to be and wanted it to be, so I'm going to redo this line. Definitely something kooky with it. Focus there, tap with the L hotkey for line. Focus here, tap. Okay, let me delete these lines now. Delete these lines. Okay, I may have to bodge this by just putting some spider webbing lines to connect to create a face where I need a face. I need a face across here. I don't need that face. Don't need that face. And we can take this over to here. And then take this up to here. Get rid of that, and that, and that. Okay, it's starting to look a little bit more like what I envisioned it looking like. Shift Control C to select all of that. This can go, this can go, this can go. And ideally when I delete this, these two faces will merge and remain. Good. Same thing on the bottom. I should be able to delete this, and the two faces should remain and merge. Very good. Technically, I think this plane and this plane are the same. Yep, so I can delete that line. Delete guides. Okay. So a couple of other tricks up our sleeve. One is that we can put some strength here. Let's say 3 millimeters. Give a little bit of strength there. And so the next question is this part watertight solid? I see some lines here that shouldn't be here. Keep spinning, I see more. Keep looking around, I see more. All right, so I'm going to turn on show hidden geometry, show invisible geometry, Control Shift X, and I'm going to turn on X-ray vision, Shift X, and I'm going to use Tools, Solid Inspector, and let it check out this solid. No errors, everything is shiny. I feel happy. I still have to do my screw hole though. Alright, if I remember right, this was 12. Looks like we wound up with 13. Okay, 12.9. So let's go 6 in. And then down here is 13. So let's go 6.5 down. So this is just slightly out to the right as opposed to dead center, but that's okay because it's getting us a little bit of room away from this part here. And I'm thinking M3. So 1.625 gives us a circle that is 3.25. So that's 3 millimeters plus 0.125 of a millimeter clearance, allow for overprinting. And experience tells me that that will be okay. So I'm going to push-pull tool, P, lock onto that point right there. And that should get us through. Oh, I locked onto the wrong point. Okay. P for push-pull tool, lock onto this point. There we go. And then I can grab this and move tool, but I'm going to press Option so that it moves a copy. And I'm going to move that and I'm realizing now that I need room. No, I don't need room on this side. I don't need room on this side because this is where the screw is just trying to bite into. I need to put that circle on this wall and then head through. So I'm going to go move that this way. To here. And I've got 5 millimeters to play with. What happens if I push this through beyond 5 millimeters? Just take it all the way on out and then hide the hidden geometry. Select, right click and intersect with selection to draw some lines here. I should be able to now delete this and this and this and this, remove this line, and there we go. So this isn't totally in the print orientation yet, but it can be moved into a print orientation, but it's in the real world orientation that it needs to be to get that part printable, to get that laser module pointed where we want it to be pointed is what I meant to say. So at this point, I'm going to take that part and the laser module and this, and I'm going to M for move tool and Option to make a copy. I'm going to move it along the red X axis over here, flip it along the red direction, move it over to here. I'll cut it for a moment so that I can delete that. I'll repaste it again, and I can now get rid of that triangle, these lines, these, and these. Okay, kind of looks like fangs on a Star Wars creature sticking off this weird robot face, but I'm okay with that. So you have just witnessed from scratch the modeling of an add-on for my LowRider 3 based plasma cutter. Oh, there's one other thing we can do, and that is we can translate this curve to this part so that it will look like more of a match. So I'm going to go in here, tap on this line. Let's do that tool select curve, which for me is Control-Shift-C. Tap on this, Command-C to copy it, Command-Control-Shift-G to exit that group a couple of times, double click on this to open it, and the Command-Shift-V to paste in place. And let's drop that line on down to this one. And it just becomes a question of how far we want to take it. I'm going to Command-Shift-C for selecting a curve and get rid of that extra lines there. And I think I'll start from right here. So I'm going to take a line from there to there, and take a line from there to there. And when I get rid of these, there will be nodes along this line that I can connect to this point to create triangles. And at that point, it's still printable. It's still got all this on contact with the print bed, but it's going to start angling up in a way that is going to make it have a nice compatibility with the finished part. So these very shallow direction changes on these faces, there's a way to automatically soften those. So I'm going to select everything, and I'm going to go to Smooth Soften Edges, tap on it, and you'll see these are now hidden lines. If I do Control-Shift-X, they show up again. Delete the guidelines, exit that group, and there we go. Laser module holders, and now it's just a matter of inserting the screw and tightening down on it to hold it, but leaving it loose until I get the rotation, get them pointed in the right direction so they make crosshairs for shining on the metal down here. And I think all that's left is to go ahead and get that oriented for printing. Let's see. I'm going to explode. This is laser holder right, but I want that to be laser holder left. So I'm going to, by the way, this thing's orientation I need to keep. So I'm going to rotate this. Let's make a copy. Move with Option, Make Unique. Making unique adds this #1 on the end. I'll change the name from right to left, get rid of the #1, hit enter, and now I will looking for my axes there. Okay, so this one is backwards. So I'm going to right click, flip along red, then double click, right click everything and go flip along red. Now that should now be mirrored in a way that has its axes normaled. I'm going to cut it so I can delete the copy of the right one that's mirrored but not really mirrored. Paste the left one in. So now I've got two parts that have been properly mirrored and named properly. So I'm going to save this. I think I'm going to print this in black plastic. So I'll go ahead at some point soon here. I'll go ahead and mark these with a paint color. But right now, I'm going to copy. I'm going to pick one of them, copy it, go Command New for a new file, and paste. And we'll see that it needs to be oriented for printing. So I'm going to go Q hotkey for rotate, tap on that point while I'm oriented on the face of that side, grab that point, and then tap on that corner. And at that point, I aligned everything for printing properly. So now if I move it, if I cut and paste and tap on that corner, it lines it right up with that corner where it needs to be. Delete these. So this one is laser holder right. Command S for save. Let's put it in its own folder. And this one is laser holder right, version 1.0. And I will grab a screenshot, and then I will export that as a stereolithic printable file, an STL file. Export. We'll create a folder for STL, laser holder right, boom. And now let's get this one. Start a new sheet in Cura and open these up in Cura. And I think these will be okay with no supports. 35 minutes, 8 grams. And so next up, I'll print these and we'll let you see how they look on the actual unit themselves.